Okay, I think we are recording. All right, so this is covering the dast-benchmark tool and how to kind of go through the workflow of adding a new application to the benchmark. So I want to quickly start with some of the kind of issues you have when you go to do a benchmark or an analysis comparison of scans to see if your DAS tool is actually getting the flaw coverage and the scan coverage that you expect. So some of the issues that kind of crop up when you're doing this is really comes down to the comparison logic. And what ends up happening is a scanner, as it's scanning an application, will be trying either random inputs or maybe sequences are a little bit different. So it'll request one page and using a get method instead of a post method first, and it finds a flaw and reports it. The other time I might do the post request first and then report the flaw. So the reports will look like the vulnerability exists in a different place when it's really the same vulnerability, just in a different, accessed in a different method. So the benchmark tool has a number of kind of techniques it uses to try to make sure that these comparisons are actually valid comparisons and not kind of too strictly doing a comparison and basically reporting incorrect results. So one thing that you'll end up realizing as you work with DAS tools is that URLs are not very good for determining uniqueness. So doing a direct comparison on URLs to see if they match doesn't actually work in a lot of cases. For example, like a lot of applications will do cache busting. So they'll append like a random ID or maybe the timestamp at the end of the URL request. And then the next time you access it, it'll have a different value so that the browser doesn't cache it. But when you go to do your comparisons, you say, hey, does this URL match? It'll be like, no, it doesn't, if you're doing a direct comparison. So what we end up doing is kind of two techniques. One is we take a report from the DAST engine and then we kind of convert it into an expected report. And the expected report really says like, okay, if you scan this again, this is the type of flaws and this is the type of resources we expect the DAST tool to have seen. That way you can kind of get a good understanding of how good your coverage is. So one of the solutions is to look at the actual values and determine if they're kind of randomized. And if they are, it'll basically ignore that. It'll say, okay, this is a dynamic parameter. It's going to change probably in the next scan. Don't pay attention to that when you do your comparison. The other one is to allow the user or the person creating the expected baseline report to specify directly saying this is not this is going to be a dynamic value, so ignore it completely. And there's a couple of things that you can ignore. You can ignore parameter names, parameter values, the entire parameter, URL paths, parts of the URL path. So it's kind of flexible and it lets you say, okay, this vulnerability is going to exist and these are the types of constraints that are really required for that vulnerability to be matched against. So besides that, you also have host names may change. So if it's running in a CI/CD pipeline, it might generate a random URL or host name. So we ignore that. We basically strip out all the host names and just replace it with a .star. Another issue is mismatched query name ordering. So some applications may just change the order. So here's an example of the first request doing x is equal to 1 and y is equal to 3. But then maybe the same page will kind of flip those parameter key values. So what we do is we basically parse out the URI and sort them so that they always match the same order. And that's, and evidence and attacks. So obviously, DAS tool has many different attack strings that it can send. So what we want to do in some cases, we want to actually ignore the attack string or the evidence. So if the evidence basically states, if it finds this flaw, here's how we determine that it was a flaw, whether it was like a URL or parts of the page that kind of demonstrate that the flaw was actually found. So in some cases, you do want to take that into consideration. For example, if it's a particular type of link that must exist, like it's missing some property that needs to exist, otherwise it's going to be vulnerable to something. So in that case, we do want to account for it. In other cases, like a SQL injection attack string, we don't care what the attack string is. So just ignore the attack string. And that attack string may also show up in the URL, so we need to cleanse the URL of that attack string when we do our comparisons, because the next time it runs, it might try a different attack string and find the same flaw. But again, the flaw is exactly the same. It's just a matter of doing a kind of decent job comparing against it. So as I mentioned, the expected report allows you to ignore various fields like the parameter names, names and values, parameter path indexes. So we could say, okay, we're going to ignore this particular path. And this kind of just walks through all of that. So that kind of covers the why it's so hard to do a comparison between two scans. Now let's look at actually how it does it. So there's two kind of key metrics that we're looking for when we do a baseline or benchmark comparison between a scan. That is the scanned resources, which basically determines the coverage of the crawler of the dast tool. So if there's 100 links and it only found 50 of them, you have a 50% scan coverage. For vulnerabilities, we have flaw coverage, and flaw coverage really depends on what type of flaws exist, how many do exist, where they exist, and other kind of properties to allow us to do the comparison. So for scanned resources, what we do is we take the HTTP method, and then we also look at the kind of transformed URL, and we kind of concatenate this or put it into just a big string with various properties removed if they are being ignored. And then we just have these kind of two sets of values that we can do a differential analysis on. So there's this diff algorithm that will basically take the two sets of all the URLs from the expected report and all the URLs from the scan report and basically go through it and say, okay, was this found? Yes or no. If it wasn't found from the expected report, then that is a false negative. And if it's something that existed in the expected report but not in the new scan, that would be a potential false positive. And I say potential because a lot of times when you're doing these baseline analysis, you as a person creating the report may miss a link that the scanner just happened to find that you forgot about. So usually you want to look at those results to see if any of these potential FPs are actual true positives, and you need to update your baseline report. For vulnerability instances, it's a bit more complicated. One of the issues that we ran across with the dast tool is it doesn't have a concept of a unique vulnerability ID. So what ended up happening is we had to go through all of the alerts that Zap could create or the dast tool could create, and then create vulnerability IDs and then use those as our kind of primary key to do our comparison against. So in the expected report, you'll see vulnerability IDs, which are subsets of CWEs. So you can see like here, 79.1, 79 is a CWE for cross-site scripting, and then 0.1 means maybe it's reflected. There's other types of alerts that may exist in the report, and I'll show those in a bit. But we go through, and pretty similar to how scanned resources are compared, we kind of create these two types of sets, and then we create a comparison of those sets. And then if it doesn't exist in the expected report, it's considered an FP. If it doesn't exist in the scan result, it's considered a false negative, and so on and so forth. So any questions so far?
Nope, pretty
Okay.
good. Thank you.
So next, I'm going to do a quick kind of walkthrough of the workflow of how you would create this type of expected report. So what I have here is a new application, NodeGoat. I did a scan earlier using it locally because it was crashing. Our dast tool was finding a flaw and crashing it, and so I got to fix it. But this is the repository for NodeGoat, and it has a customized CI job to basically build it as an image and run it. So this CI template will create the image of the NodeGoat application with Mongo built into it. And then we have a secondary project. You could put it in the same one, doesn't really matter, but to actually run the dast scan to get the results. And then we download the results, and this is kind of the end product of that. So this kind of just tells you if you're going to benchmark an application, this is how you would set it up. So what we end up doing first is a lot of times when you're creating these expected or baseline reports is you don't want to do everything manually. And the scanner is going to find stuff that you as a human either will miss or it's just too tedious to report everything. So what we end up doing is we take this, let's open it up real quick. So here is the report. It has all our flaws, all that good stuff in it. And we're going to take this and actually generate an expected report from it. So it's going to go through and do that for us. So we go and we do dast-benchmark, and we're going to do a convert, report, node-goat. And by default, it will output a expected report. So if we open that up, big again. So this is what the expected report looks like. It has some configuration stuff, rule files, etc. But here you can see the evidence. In this case, this evidence is important. The attack was not included, and it just has these different types of instances. So each flaw obviously can be found multiple times, so we want to account for that. So this one was anti-CSRF token scanner. Here's 79, which is cross-site scripting. So you can see in the post username of the sign-up page. And if we actually look at this in the here, we could actually take this attack string. It looks like it uses a single quote, double quote, and then a script. Single quote, double quote. See, I've already tried this once before. And I believe this attack string actually doesn't work. But if you kind of modify it a bit, it does work. So it actually found a flaw. It just kind of reported it incorrectly. So it's not really an FP, but if it was an FP, what you would end up doing is you just delete this instance from the expected report. That way you have a clean result set. So that's pretty much what that looks like. Move that over and then go back to our workflow. So we've converted the expected report now. As I mentioned, verify the results. You want to go through each attack and make sure they're legitimate. There's times when you need to, quite often actually need to go through the report and kind of modify it, whether it's removing parameters or ignoring parameters, or just making it so you'll be able to do a better comparison overall. For example, I think what was this one? Nope. Just go through. All right, so here's a great example. We have CWE 16, which is the content security policy issue. And a lot of times this will exist on like every single page that it tries to find because it's missing the CSP header, or the CSP header has some sort of, in this case, it's a wildcard directive. So a lot of cases you could probably just say, okay, this is going to be, no matter what, if it's found in a post request, it's going to be the same flaw. In this case, the URLs are different, so we might want to keep that. A lot of times you don't want to keep that, but it really depends on the flaw itself. Or what's another one? Directory browsing. Here we go. So you can see here's a GET request and a POST request to the same exact URL, the same evidence. So it's like, okay, this is clearly the same flaw. Let's just delete that. And then we're going to mark this as it could be either POST or GET or any other thing. Same with these ones, but we're not going to bother doing that now. So we're going to save the expected report. We're going to go back to our, over here. Oh, this one was actually good because it actually showed, let me see if I can find that, the learn. Okay, so here's one where we don't care what the parameter value is. This could be anything. It's still going to be the learn URL with the URL parameter as being the actual vulnerable endpoint. So what we do is we delete that and we say we're going to ignore the parameter URL because we don't care what the value is. If it matches this, then we're good. So add that and then go back to our results. So at this point, let's consider this expected report verified. Everything looks good. What we might end up wanting to do is to, for example, add some new URLs to it. So let's say we found some new URLs that we want to add to this report. So we're going to do dast-benchmark, and we're going to do add URLs, but we just want the template, so it'll spit out a little file for us. So this CSV file gives you everything you need to know to add new URLs to it. So let's open that up. We're going to add, let's see, http:// some new URL. And then don't care about pass, don't care about parameters. Let's add another one. 2. Okay, so we're going to add these new results, add these new URLs to our expected report. And add URLs. expected report, and we're going to spit out a different one, expected report with URLs. Oop, and I spelled it wrong. All right, so now if we do a diff of our expected report and our expected report with URLs, you'll see that it added these new URLs for us. So the next time we do our comparison, it'll include these as well. So that's great for URLs, but sometimes you need to add new vulnerabilities as well. So sometimes you as a auditor will be looking at the code and say, hey, this was a flaw that the dast tool missed, so we need to add vulnerabilities as well. So there is tooling for that as well. Add vulns, template, again, spit out our vulns.csv. The rules, you kind of need to know the vulnerability ID and CWE ID. So there's another kind of command if we do dast-benchmark with and list rules. Oh. Is this an old version? Oh, there we go. So this is kind of what the rule list looks like. So it just has the vulnerability ID. It has a CWE, kind of it's actually the Java class name minus the .java. And then this is the alert title. So we key off the vulnerability titles because again, there's no concept of a unique ID. So we key off this vulnerability title, and then we assign it this vulnerability ID. So that's, and these true false are for ignoring parameters or ignoring evidence. So for example, if we want to add a new cross-site scripting one, we would do this, but then we would grep viewable. So let's say we want to add a, where is reflected? As reflected. So 79.1. So if we open up our vulns, so we have a vuln ID of 79.1, CVE is 79. Let's say the attack is script alert 1. Evidence, script 1. Method, let's say to get, let's say parameter is user, URI is login, and we're not going to ignore path, we're not going to ignore parameters or parameter names. So now we have a new flaw. Now we can add this to our result. Expected report with URLs out. Report with URLs. So you can see that added a new instance. And again, if we do a diff of expected report with URLs and expected reports with URLs and vulns, you'll see that it added this new attack evidence to the login URI, methods get, parameters user. So this just makes it easier for you as someone trying to add new vulnerabilities to a baseline report to not have to go through and add all these JSON fields and try to get all your syntax correct. It'll just read the CSV file. And you can add new lines if the evidence requires new lines. You just double quote it to lock it in. So now we have that. We have our vulnerability added. So now we can do a comparison. So let's say we had either a new scan or we just want to compare what we kind of converted this no-go full AJAX report to our current expected report. So we're going to do dast-benchmark again. And again, this is all done in a CI job as well once it's added. We need to set the app name. Let's say it's no-go. Scan type is full AJAX. Report is no-go full AJAX. Expected is remember the, yep, expected reports with URLs and vulns. So by default, it will spit out, so you can see here, it found a number of duplicates. So this tool, the dast tool, will account for duplicate false positives and duplicate false negatives, false positives. A lot of these vulnerabilities are kind of found multiple times and it's a very similar place. So we count those as duplicates because they're not technically unique. So now we have a benchmark results. We open that up. And you can see what it does is it creates statistics for each type of vulnerability ID. So in this case, there's 182 true positives. This is user agent fuzzer usually does a lot of stuff. I don't really consider this a true positive. I would probably remove that and consider this whole class of issues as being a false positive. You can see for each one, there's like true positives, duplicate true positives, and so on and so forth. And also another key metric is the expected true positives. So if there's only supposed to be 3, you need to match those against to see if they actually have the correct number. We should see one FN. As you remember, we added that cross-site scripting flaw. Obviously, it's not going to exist in the report because we just added it. So that's marked as being a false negative. And then we had a number of duplicate true positives. We had 443. This is obviously, again, because we didn't really clean the report, it's going to have a high number of true positives. And it gives a total of the scan coverage and flaw coverage. So that pretty much concludes how the dast-benchmark works and kind of the workflow for creating these reports. So yeah, any questions?
Pretty awesome, pretty awesome. No, it was very clear for a new starter.
Yep.
Yeah, I'm just thinking, so basically what one needs to do is to convert kind of their dast results into a particular format, and off you go.
Pretty much, yep. Yeah, and then, I mean, you'd want to manually verify a number of stuff. Obviously, the verification process is the most time consuming and requires the kind of skill set that you need for identifying these types of issues, especially if you're trying to add new vulnerabilities that the dast tool has not previously found. But overall, if you wanted to just, for example, take this expected report and then use it to do a kind of base comparison to say, okay, if I ran one scan and I got these results, I'm going to generate my expected results from that one scan, do a new scan, and how much does it differ? Am I finding like 50 new vulnerabilities? That means there's some kind of variancy with your scan, that maybe the dast tool is doing something wrong or found something new. So you could still use it even if you didn't really comprehend or didn't really have the kind of background knowledge to really verify and add these new flaws. You could still use this information in a kind of a QA setting. So
nice. Are there any, by chance, like already existing tools that we've compared, something open source potentially?
So right now this is kind of forced to our report only. There maybe in the future it would be nice to be able to compare against like how other tools, like how does Burp do and how does whatever do. That would be nice, but I think for V1 we just want to be able to use this tool as more of a QA process to make sure that our scanner is getting the proper amount of flaw and scan coverage. So
absolutely. Any fancy graphs?
I do. So once baseline application is in the dast-benchmark, it's stored in here. We have our reports. Should put that further up. Let's maximize this. So every time this dast-benchmark master branch is run, it will generate a new entry. So we can say, let's take a look at DB. Right now, only DVWA is in there, but we're going to load that up. And this gives you a nice, like, okay, we got 48% scan coverage, flaw coverage looking good, above 70%. And then for each different flaw, we can see the expected versus how many it actually found. And again, false positive rates, false negative, duplicates, and so on and so forth. Now, if you want to compare that, let's say with a previous run, let's do full Ajax 3. So we're comparing this with the previous run, so we could see kind of the difference between the two. Oh, did I just get bit by the demo gods? I might have. I'm not sure why it's not working. Let's try it again.
That's probably an Ajax.
Yeah. All right, so it worked against the, that's weird. I don't know why it worked. Let's try it. Something. Oh, there it goes. That was weird. Okay, so here is doing comparison. You can see we got the same exact results, which is good. This is what you want to see if you run the same configuration against the same application twice. So yeah, and then I don't have the tables doing comparison just because the tables are kind of hard to work with. But yeah.
Well, I definitely appreciate the GitLab UI library, which is great. Graphs
Yeah.
are great. It's really nicer to sort of visually assess the results. Oh,
Yeah, and
look at that beauty.
if you wanted to look at the chart view of this would probably be easier for you to look at what was different between. Obviously, these are all going to be the same bar charts because it's on the same exact issues. But if we compare it against like a baseline, which doesn't do actual attacks, you're going to see very different results between the two if it loads.
Meanwhile, while it's loading, I was curious. I don't think I've seen anything in the rule set around headers. Is it something that we intentionally omit, or is just like it's up to the test itself to whether to use headers or not? But it seems like everything is around query string and HTTP method.
So correct. We don't. So the header would be included in. If we open up the expected report. So in this case, for the evidence or the parameter rather, I believe it would be the header name would be the parameter value in here.
Okay.
So it would still, as if you were, let's say you were attacking a header and the parameter, the header name was like content type or something, then that parameter value would be filled in here.
Got it.
Yep. And also, I believe they are working on adding evidence of HTTP headers into the newer version of the dast tool. So now when you open up a vulnerability report, you actually see the request headers. So that should help doing comparisons as well. Yep.
Well, I don't have any more questions. It's been pretty detailed. The next step is just to dive into the code and see for yourself, I guess.
Yeah, and I'm open to people creating their own baselines to help me out because it's a lot of work. But yeah, next one is Node Goat. Hopefully get that added soon.
Right. All right.
Right. That pretty much is the recording. So I'm going to stop recording.